Welcome. Suppose that on the midterm for a statistics course at Anytown University, 14% of students earned an A. Of the students who earned an A on the midterm, 46% went on to earn an A on the final exam. Of the students who did not earn an A on the midterm, 12% received an A on the final exam. Now let's identify some events or label some events. We're going to let M be the event that someone earned an A on the midterm. E is the event that someone earned an A on the final exam. Part A, sketch a tree diagram representing this scenario. So we were told that the probability that someone earned an A on the midterm is 0.14. Now, if someone earned an A on the midterm, they could go on to do two things, either earn an A on the final exam or not earn an A on the final exam. We're told that students who earned an A on the midterm, 46% of those students also earned an A on the final exam. So this becomes 0.46. All right. Now, what's left? Well, students earned an A on the midterm or they did not. So students who did not earn an A on the midterm, we can denote that with M bar or M prime, and that is did not. Did not earn an A on the midterm. So the probability of M bar, that's equal to 1 minus 0.14, and that works out to be 0.86. Now, of the students who did not earn an A on the midterm, so that's these students, 12% received an A on the final exam. So I know that these students here did receive an A on the final exam, 0.12 of them. Now, let's fill in these blanks here. So someone either earns an A on the final exam or does not earn an A on the final exam, and we're going to use the same notation here. That's E bar, also sometimes denoted as E prime. That's the complement. So these are students that did not earn an A on the final. So this one, so students who earned an A on the midterm but did not earn an A on the final, they have that probability is 1 minus 0.46, and that is 0.54. So of students that did not earn an A on the midterm and did not earn an A on the final exam, those were 1 minus 0.12. So that probability is 0.88. Okay, now suppose you're a grader or working in this class and you select a final exam at random, and that final exam has a letter grade of A. What is the probability that the same student earned an A on the midterm? So what we're actually looking for here for part B is the probability that someone earned an A on the midterm, given that they already, or you know that they earned an A on the final exam. Well, that's the probability of both of these events occurring. That's the probability that a student earned an A on the midterm and on the final exam, divided by the probability that a student earned an A on the final exam. Okay, for the sake of space, I scooched that over a little bit. So first of all, how do we find the probability of M and E? That is the probability that a student earned an A on the midterm and on the final exam. Well, students who earned an A on the midterm, they're here. And of these students, 0.46 of them earned an A on the final exam. So what that tells me is that the probability of M and E is equal to 0.14 times 0.46. And that works out to be 0.0644. Okay, so now what about the probability that a student, earned an A on the final exam? Well, that can happen two ways. It can happen here or here. So this probability is worked out. The probability of E is worked out by adding 0.46 plus 0.14, and that gives us 0. Oh, excuse me, I wrote this one down wrong. This is 0.1. This one here, it is not 0.14, it's 0.12, excuse me. Let me fix that. There it is, 0.58. So that's this probability here. Okay, so what this gives us is the probability that that student whose exam you're holding, and it has an A on it, it's a final, the probability that they also earn an A on the midterm is 0.0644 divided by 0.58, and that's equal to 0.1110. I hope you found this video helpful.